So the first person is going to be Alexander Neumann. And he's going to speak for 5 minutes about 5 tools, and the time starts now.
Okay, great. I'm sorry, but I will be very fast. So I wrote a few tools in the past several years, and I'd like to just show them to you. The first one is called Build Go. And what I noticed when developing another tool that I'm going to talk about in a minute, that it's not so nice for like end users to install Go tools. For example, you can get the latest master of the tool called Restic. Then you can just use Go Get, but this is not so nice because when you call Restic version at the bottom of the slide, it will just say compiled manually and just the Go version. And when you extract a release tarball, you need to go do all the magic with the Go path and so on. And that's for end users, and that's not nice. So I wrote a small Go program called build.go, which you can just run with Go run, and it has a build tag of ignore, so it's not compiled with the usual Go code. And you can use it from a checkout of the Git repository, and you can also use it from a release tarball, which means that you can just clone the repo, go run build.go, or extract the tarball, run the same command, and then there you go and have a nice version number. And for end users, that's really great because they don't have to fiddle around with the Go path and so on. You can find that tool on that program on GitHub. Just copy it to your repository, use it. There's a small configuration setting at the top, and that's it. Bonus is it also supports like cross compilation and CGO and all the other stuff like build tags. Next tool is called Machma, which is a colloquial German term for just do it. It's nice because then you can, oh, I need to do this. Okay, apparently. Okay, I cannot reload the slide, sorry. What it does there is there's a find command which finds all the images in the current directory, pipes it to Machma, which runs the mogrify command, which is used to resize the images. And by default, and there you can see it again, by default it will run on like 4 worker threads, which means it's optimized for my machine, which has 4 CPUs. And you can see it while it's running, it will compute the time it will take to go through the complete list. And it's much easier to use than xargs or even GNU parallel. So to just pipe it in, give it the command, and it will do its thing. You can also do that with, for example, IP addresses and ping them when there's any like sort of error or something like that. It will report it to you and write the IP address or the string that you piped into it just before the output, so that you can see what the error, what has caused the error. Yeah, you can also do that and some other demos. Next tool is Groby, which solves a problem that I had when I'm running the i3 window manager on Linux. Whenever I plug my laptop into the docking station, then I need to manually call xrender and configure all my monitors. And then I wrote a shell script for that, and everybody has written such a shell script, and this is really, really, really bad. So I wrote a small Go tool for that, which automates calling xrender, subscribes to screen change events, so you don't need to like call it in a loop or so. And it has a simple configuration in YAML. For example, there I have like a rule called docking station. I'm selecting this rule based on the connected and present outputs. And then I say that, okay, configure a row of HDMI 2 and HDMI 3 side by side, and that's it. And there's also like a TV rule where there's a serial number of the TV used for matching, and fallback, which just enables the internal display. Then you can run it once. It will say, okay, I detected this configuration, calls xrender, and everything is great. Or you can run it, for example, via systemd and use Groby Watch, which will just subscribe to the exchange events and also regularly poll xrender if there are any new outputs, and it will just configure this. So now when I plug in my laptop into the docking station, it will just switch on my external outputs and everything is fine. So next one is dux, which is a small command that I'm using to track differences in output for commands. For example, here in the configuration, I have configured a command which just runs the date command on Unix, and I've configured that it should it shouldn't run faster than every 5 seconds. What the dux command does is, on the first run of the output, it will just save the output, in this case the date, to a state file. It makes a note of when the command was last run. On the second run, there's nothing to do because it was just 1 second after the first one, so the command isn't executed at all. And on the third run, you can see that I waited a few seconds and then the date command was run. The output has changed and there I can see the diff. And I'm using this one to, for example, run this in a cron tab somewhere and have a find command running which reports all the things that are there. Yeah, last thing is restic. It's a backup program written in Go, and unfortunately my time is up. There's the nice logo. Have a look at it. I have stickers. Find me afterwards. Thank you.
Awesome. No. It doesn't work anymore. Yeah, mics are awesome. Awesome. Really good job. And now we have Secret. Oh, that's the timeout. So please come in. So Luna is going to be talking about something else. I have no idea. It is very annoying. You're gonna need a mic.
This is working.
I'm not holding it.
I'll put this here while I set up.
Yeah.
Does that work? Yay, screen.
Setup time should be part of the 5 minutes.
Seriously. Screw this.
Oh, the slides for the yes. Send them to. For the next speaker, this time will be part of the 5 minutes. So, no pressure. You know.
All right.
Take
No, I
your
can.
time.
No, I can do things.
Showing your private Twitter to people,
Me too.
and now it's showing Gmail. Wow.
All right.
Use the mic.
Can people hear me? Yes, good. Okay, so I'm going to give a quick talk about a tool that I wrote called Instrumented SQL. It is a tool that lets you log or trace any and all SQL statements that run in your code base by wrapping any SQL driver and exposing its own driver. So how it works is that, let's open up the examples. You can wrap any driver, for example, MySQL. You call instrument SQL.wrapDriver, and then you pass in any tracer. Right now we support Open Tracing, Google Stack Driver Tracing, OpenCensus, as well as Amazon X-ray tracing, and any SQL calls that have a context attached to them. So that means you have to call query context instead of query, because otherwise we have no idea where to send your trace, will be sent to the corresponding tracing tool. What that then lets you do is that, for example, in my case, we're using Stack Driver, and we then get a lovely trace in our Stack Driver display that looks like this. For example, you can see that we're spending half our request doing I don't know what, and then we spend about the rest of the request doing SQL queries. And as you can see, we're running lots of unrelated SQL statements in series, which we could potentially improve by running them in parallel. That's it. Questions? Shock therapy.
Boom. It works. Cool. Okay. So, yes, very sensitive. Very sensitive. Be careful. It's also very. No. And I think it's already connected. So if you move to one side or the other.
That's not mine.
No? Oh, you send more things. Okay.
Yes.
This one.
That's fine.
Perfect.
Hi everyone. In this talk I'm going to talk about TensorFlow and Go. And this may look a bit like a lecture in a university, so it's great. Let's look at lots of numbers. And what is TensorFlow? TensorFlow, so the official definition is that TensorFlow is an open source software for machine intelligence used mainly for machine learning applications such as neural networks. Essentially, there is a tensor and it flows. The tensor is an abstraction of a very complex mathematical concept. Think of it as a vector or a matrix that can be of a very high dimension. A tensor has two properties: the type of the data inside, for example int, and the structure of it, or the shape of it, which is essentially the number of elements and the number of dimension and the number of elements in each dimension. The second part is the graph, which is also called model. And every step of the computation is called also, every node is also called an operation. And the tensor, or the set of them, essentially flows, and every step a different computation is happening. And you can evaluate the value of the computation at any node, and you obviously also have an output. This is essentially neural networks in 20 seconds, half a minute, and this is also TensorFlow, what it does. And there are several APIs that are officially supported in TensorFlow. Go is one of them. Obviously, Python is the most widely supported one. And the features that you have for Go in the APIs of TensorFlow is to train models and consume those trained models. All the models are written, or practically most of the models are written in Python for data science reasons. So I am helping organize this really cool challenge that is called Blacklight. And by helping organize, it means usually there is a challenge, and then I'm being asked, hey, can you solve it and say that this is something you can solve in a reasonable time in a competition? And one of the challenges is breaking into an interface that controls a camera, and this is how it looks. So you have to guess the pin, and you have to write the CAPTCHA to prove that you're a human. And the steps that I decided to take for this specific proof of concept is to use Go for the machine learning that trained basically this CAPTCHA. So a saved model, which is kind of the brains, you can say, of the model, was provided, and it could recognize numbers and translate that into the string that is the digit. And my plan for breaking this screen that you saw was loan this trade model and then write a script or a code that essentially guesses every password with brute force, and through this TensorFlow help just gets the CAPTCHA for it. And that's how it was. And it was a great success. This is how it looked in the competition in real life. This is somebody actually managed to break. I don't know if you can see, but this is the IP of the camera. And yeah, that's it. You can read the full details at the Gopher Academy post from December 28th this year. And you can also find there a link to the repo with the full code. Thank you.
Thank you. David Le Corfec. Yeah, that mic is suffering. Yeah. Do not drop this mic. Who's the next speaker? Cool. Please come up. Okay, you're there. Cool.
You need to speak out.
Oh shit. Okay. If you don't really need to use your own laptop and you can just send me the link to the slides, that's easier because there's less cables moving around. Okay. Okay, so let's move it to real quick. base. Cool.
Okay, so
Usually, not use that one. Just use it.
okay. In process caching, so the context is writing a web service and serving read-only data, but you have to compute some expensive stuff or call slow or unreliable web services. And well, I hope you cache already because you have to cache all the things. And I was a bit lazy and I didn't want to deploy some memcached already. So. But your mileage may vary. So it's very important, in my opinion, to cache everything. Because it's the less you do, the less you pay for. And avoid network calls because I don't like network and network sex. Plus, we have seen already today that the fallacies of distributed computing is very nice. Okay, so the first simple cache is memorization. You have a kind of a map with key and values to store cached items, but it's kind of limited. If you have very big objects or a lot of objects to store, you can run out of memory. But sometime, hopefully, some data are more frequently requested than others. And it's kind of Pareto distribution, if you have already heard of that, or ZPF law. So you have some videos that are more popular than others, and it's important to cache the most popular stuff. So it's a good trade-off to use a cache small enough to keep the most popular items and evict the items you don't need anymore by least recently used eviction. So there's a simple package for LRU cache by Bart Fitzpatrick in Group Cache. It's very simple to use, but it does not support TTL for entries and does not support concurrent access out of the box. There's a way more powerful cache, C-cache by Carl Sagan, with support for TTL and pool, different pool protected by mutexes for fast and safe concurrent access. But beware of the thundering herd when multiple go routine at the same time want a missing item. They will fetch it at the same time, and you can do bad things to the slow service behind. So you can use a cache lock by implementing a map. It's just an example there. But you can also do better if your constraints allow it by serving a stale content where the TTL is expired and asynchronously fetch the missing item. And you can also use a channel and a pool of coroutines to limit your concurrent fetches to not hurt so much the slow and unreliable service behind. Thank you very much.
Thank you. So, Fabian, you don't have slides? On my laptop, cool. What is your talk about?
It's about calling git test and automating it, and git bisect and automating it with Go test. Sorry.
Where did you send it?
I think it was on your browser already.
I was talking to you, but it's
That one.
is that?
Yeah.
Cool.
Okay. Thanks.
There you go.
Thank you. All right. Hi. Hello, world. As I already said, this is about calling git bisect and automating it with Go test. It's a trick I recently learned. There's a solid chance this is nothing new to you, and if that's the case, I'm very sorry. I apologize. Then just shut off and shut down. So I had a huge code base, you can see it here, and this code base was pretty solid for most of the time. And since I wrote this, many commits were added, and at some point a bug was introduced. And what I was thinking of my code base, how I remembered it to be, was not true anymore. And I'm really sure it wasn't that a long time ago. It was very solid before. But my tests, they only cover the bugs I already thought of when I wrote the code. So the bug, I could have introduced it in a gazillion of commits that have happened in between. So how do I find it? So my favorite tool for doing this is Git bisect. If you never used Git bisect, it performs a binary search on the commits in your history, and you can mark commits by testing them as good or bad. And due to the binary search and the logarithmic effort it has, you only need a very few test cases to actually find the commit who introduced a bug. Normally I do this manually, and I found it a bit cumbersome. You go on and you say call git start, you mark initial commit as bad and good, and then you just repeat the process on and on and on. And hey, repetition, come on, we're engineers, we can automate this. So the Go test is actually a very good way to automate this. You can actually create a new Go test for your regression bug you just identified. You know it's in there somewhere, so just write a test case that will actually pass when the bug is not happening and fails when the bug is occurring. And if you write this test, put it in a separate test file. Do not commit this file yet. Don't put it into your repository, otherwise it will get lost when you travel back in time in the history of your repository. And then you just start as usual. You call git bisect start on your repository. You know it wasn't there in the beginning, so you just mark the initial commit as good, and you mark the head of your current branch as bad. And then you can actually do git bisect run and let git bisect run do its magic. And git bisect run is cool because it expects a command that returns with an exit code of 0 if your code is good, and returns with an exit code of 1 if that's not the case. And if you repeat this, actually after about 5 to 10 seconds, you have found the commit that introduced your bug. And Go test is perfect for this because now you already have a test case for this regression case. Now you can just commit it. You have found what's going on. You can have found what commit introduced the bug. You can put it in the repository, and that's actually all there is to it. And this is really neat for automating stuff, which was bothering me quite a lot before. So I was able to find, yeah, I have introduced the bug myself, and I committed this test. I changed the code to be correct again, and I'm done. Cool thing is, this is not limited to Go test. You can actually do it with any command that returns an exit code of 0 on success and an exit code of 1 or something else as 0 on failure. Go is perfect because you can also write a very little tool and call this with Go run. And the combination of git bisect and Go test can actually help you to find bugs much faster. Thank you.
Well, that's my charger. That's okay. Thank you. How many of you have used git bisect before? Okay, good. The rest, you should use it. Florian. Yes. But not for GopherCon Iceland. You have another talk. Come on. Is that on the slides here? Do you need your... He brought his data center. Look at this. Okay. Yeah. Whoa.
Which one do I need to use?
What do you want to use?
Well, I can use anything.
What board do you have?
I don't have VGA, rest I have. Yeah, it is.
They have mini display. I don't think so.
Yeah, I have mini display.
Oh, mini display then. Oh, that is USB-C.
Oh no, I have USB-C, but I've never used it.
Well, try. If not, I can switch to mini display.
Right. Right, it doesn't want to detect any.
Okay, so let's try with the other one.
Which one? It's there. Yep.
looks like it fits.
It does fit.
Cool.
This one was can I do full HD?
You do you. So actually 720 is probably better, but I'm not sure. So fun thing about this guy here, other than co-organizing GopherCon Iceland, he's also maintainer for you're maintainer, right?
For what?
For one IDE.
Well, I contribute to it.
I contributed to one IDE, and you'll figure out which one soon.
Yeah, thank you. So hey everyone, I'm Florin. I organized the London Go meetup with some other people. I organized the GopherCon Iceland with Natalie. We'll talk about it soon. But now I'm here to talk about the Go IDE from JetBrains GoLand. So I'm going to go quickly through a couple of features that it has, and I think you should give it a try. It's going to be a bit hard with one hand, but let's see how it goes. So, no, I'm not saying. So, let me, give me a second. No, it's fine. It's fine. Right, so hopefully everybody can see this, right? So in Go, it's really boring to handle errors properly, right? So we can do something like error dot not nil, and you have that type of completion, and then of course you're a good gopher and you're handling the error like a true gopher, panicking, right? The other thing that you can do quickly with the IDE is whenever you have a query, so sorry, DB. Yeah, it's hard. English hard. It's fine. So the IDE, like you saw, I just typed db.q with smaller case and it just worked. And now if I start typing within the query, let's say select, it will automatically start completing the SQL query and so on for me. If you tie the IDE to, let's say, to a database from, in my case, I have a database, it knows already where to connect and so on. So you can do lots of cool things with SQL if that's the database of choice. But switching to another project to show some other cool features, this one will require three things. So I'm in the Kubernetes project because that's a fun one. And let's say I'm looking at this function. I've just opened a random file which is under, I don't know, kubectl apply.go. I have no idea what it does. So I would like to change this function. I would like to refactor it, right? So the IDE knows already to suggest some possible names for it. And let's say I want to rename it to lowercase get, right? And the IDE will say, oh, well, here's what you want to rename. Here's the files, and you can preview what's going to be applied. And it also knows how to search in comments and so on. So whenever you want to refactor something, you'll be able to see what's going to be changed for you. And you can do that. So I just messed around with Kubernetes, but now let's say, oh, I realized I've done a mistake. I want to go back. There is a thing called the local history. Show local history, and then you can actually see what happened with the refactoring or with any changes that you're doing, right? Okay, cool. Undo that, so you can undo that and it will undo everything. And the last cool feature, there is a, let me, right, no, this one is actually cool and I want to show it, I don't care. You have the call hierarchy of any function. So yeah, show it. So you can take any function and you can see the call hierarchy for it and all the callers for that and so on. And you can understand where the changes propagate and so on. Thank you.
Thank you. The last question is, how do you exit?
Oh, come on.
Call on Q? Bye. So that's probably mine. I don't know. So we're going from the co-organizer of GopherCon Iceland to the one of the co-organizers of GoLab in Florence. Giovanni.
Hi. My talk is not about the conference, but it's about a project I made in my free time. It's a Nintendo DS emulator, 100% written in Go. So a Nintendo DS is this handheld console. You know about it. It's two CPUs, ARM9 and ARM7, has two different 2D GPUs, one per screen, and one 3D GPU. And a lot of bunch of hardware that you also need to emulate, like DMAs, timers, and whatnot. So first you need to write an ARM7 and ARM9 interpreter from scratch. And so basically you write the standard pipeline, fetch the code execute of a CPU, emulate that in Go. You can see on the right the code is basically the main loop of the interpreter, fetching an instruction and running it. And I used to have a lot of unsafe code in there, but then like late Go version optimized it a lot, and I went back to idiomatic Go with slices and everything. And really cool job made by the Go maintainers. And then each opcode, of course, you have to write a lot of functions like this one. This is like an add opcode, and I did it with code generation, so it's about 26K lines of generated code, because it's mostly, like, of course it's different, but it's similar, and some generics, of course, would help here. And then I also write a JIT compiler, because it was fun, so it's like a hand-roll JITs from scratch. It's about 2,000 lines. And it got no optimization, just a straight translation from ARM to x86. And it's a little bit buggy, but it works. And this is an example of the code. So basically, each of those calls emits one x86 instruction that will later be executed. I got a test suite for the JIT so that you compare that it makes the same results compared to the interpreter. I wrote a little debugger, because otherwise you don't understand what's going on. And for the GPU, it's about 2,000 lines of code. It's based on SDL, just to open the window and then drone it. This is an example of a function drawing like a sprite. It ran in parallel with the CPU emulation within different Go routines. And it kind of works. I mean, it's not very fast, but it works. And for 3D, again, it's a rasterizer from scratch. So this is an example of a polyfiller doing like a polygon with textures, pixel by pixel. There is a lot of duplication here, so I went for a code generation for the rasterizer as well. It's about, you see, 34K lines of generated code for this. And so basically, at the end of this experience, what is missing in Go for this kind of project? More optimizations, because it's still not what I can get with C++. If this was written in C++, it would be faster. Operator overloading is very useful for like geometric code, because you have vector matrices and you want to have classes with operating overloading. Otherwise, your code looks like shit. And also some kind of parameterization in your code to avoid like code generation. You don't need full-blown generics. Actually, I have a proposal for this that I will submit to Go about like a kind of parameterization that will be enough for my case. And then for the JIT, you need some runtime API to register JIT code into the runtime, because right now I need to, if I turn on the JIT, I need to disable the garbage collector, because otherwise it will panic, because it doesn't find stack maps for the generated function. So, a little demo, because video games are cool. Oh! Let's do like this. No, it's not your computer, so I don't have a demo. So, yeah, sorry, I thought it was mine, that I have a real demo. This was just video I forgot to share, so I'm sorry. I will tweet the link for the videos if you want to have a look, but it's just video of video games running in the emulator, of course. And that's it. So you can look at the code from my GitHub repository, and this is just a Latin talk. If you want to, I will give a full talk at the GoLab conference. We have some stickers and discount coupons here are available later if you want to pick them up. Thank you very much.
Thank you. Important question: is the CFP open?
It is.
Cool. So if you want to speak in Florence, just find the website golab.io. There you go. And Florian and Natalie. Oh, there you go. They're going to be talking about a different conference, which is not GopherCon in IN, that is India, is IS.
I can do the holding this time around.
Are we?
Yeah. Clearly not optimized for this.
Oh no, already?
Okay. So, right.
This is a very cool gopher that Ashley McNamara made for our conference, and this is why you should come to Iceland on May 31st through June 2nd. Yes, there'll be cool swag with this gopher. Other fun stuff you should know about our conference is that at least one of the workshop givers / speakers is in the crowd. One other speaker was in the crowd earlier, gave a talk. So we already announced 3 speakers. This is JBD, Peter, and Chris. We have 5 workshops that we're going to give on May 31st. The talks will be June 1st, June 2nd. This is a great time to go to Iceland because it's almost full of sun. Our call for papers is open. Other open call for papers are, I'm reading this all from the Golang/Go repo. In the wiki you can find all of this. But you should submit to our conference, and you should also submit to GopherCon Brazil, GopherCon in Denver, GopherCon in Singapore, GopherCon India is already closed, but you can attend it, and GopherCon Russia is probably also closed, but you can attend it as well, and GoLab, and there is .go in 2019. We don't have prices yet. We promise to announce this soon. We promise to announce the ticket sales soon as well.
Right, and if you have any questions, you can find us either here or on Slack, on Twitter. Just feel free to ask us anything. Yeah, we look forward to see you there. And yeah, the call for a paper is open, so do submit your talk, and yeah, we'll do our best to see you all there. Thank you.
Do you want to use that one? Okay. It's a USB-C. Okay. No, just put this there. That's it.
Okay, I'm going to get one of these pop-ups.
Yeah, it's going to say that you want to install it, just say no.
Oh, okay, now it works.
Also, if you want to use the clicker, you can use the clicker that is right there. It's already connected, so everything should just work.
Can I go present?
Yeah, it was in present. If you plug it.
Yeah.
Yeah.
I see. I'm going to.
So, fun fact, I will go to Iceland, and it's right before my birthday, so I want to celebrate there. So, thank you. My birthday is the 6th, but I celebrate it for a whole month, so why not?
Wait,
He's going to be talking about maps.
yeah. How do I try? Where's the thing? Yeah, it's here. What? There we go. Nice. Yes, hello. My name is Michiel. I am going to present Duit. I call it Duit in Dutch. You can call it Do It in English. It is a developer UI toolkit. Management summary is it is in pure Go, *. So it is in pure Go. Currently, however, there's a caveat. You need a separate program to actually do most of the windowing stuff. In the future, it's going to be eliminated and will be a pure Go library. But it works already now, so it's a good trade-off to get started. It is cross-platform. That means it runs on Linux, BSDs, macOS. It probably also runs on Plan 9 because there's Plan 9 technology involved. Proven technology. It will run on Windows. There is sort of all the parts of the code are available. I just have to put them together to make it actually work. Then, of course, it is a UI toolkit, which is really great. And it is for developers, meaning, it's my time. The time is limited. I'm not going to write fancy features like animations and stuff. So it's going to be simple, which as a developer I really like. And also, so you can't complain about some kind of the missing stuff unless you fix it yourself. So, to prove this is real, I have a little demo, I think, of actual applications written with this library. Because, of course, if you write a UI toolkit, you also have to write application to use it. So I've done a bunch of those just to figure out how it works. And then, of course, I had to go back and change it all. But that means, in the end, things do work. This is one of the map applications I made. So it is just running on macOS and very smooth, as you can see. There's some double clicking. Oh wait, probably I even have internet connection. Okay, so that's the first application. What this shows is absolute positioning, basically. The map is on the back, and on top of that, there's some buttons here, there's some buttons there. Next application. This is actually why I started writing this, because I wanted to make an application. Then I looked for UI toolkit. Didn't find the one I needed, so I started writing the UI toolkit. This is a database kind of application. These are the database connections here. I sort of trimmed it down a bit to make it fit. These are all my databases on my local machine. I can select one. There's a bunch of, well, there's a table where I can just write the SQL and execute it. And then the results will be in a table view there at the bottom. I can just also select one of these things probably. Yeah. So I need a bigger screen. Well, then it just shows all the data in there. There's like a tab thing where I can look at the structure. So this is, of course, not a polished thing. I basically wrote it to get a better feeling for what I needed in the toolkit. Then there's this one, which is a sort of a proof of concept of a mail application. So there's some bunch of mails here. It's a bit slow now because it actually had to render some fonts. There's some font awesome icons here just to make it really cool. You can see the rounded corners. I stole the blue colors from Bootstrap, so it's really up to date with the latest expectations from the web crowd. So you can't complain that it's ugly or something. So because it's all standard stuff. So most of the stuff is pretty functional already. You can select stuff. You can loading a font. So I can stand it. So it works. It works. I promise. Does anyone recognize this program? Yeah. So this is Acme, except of course, as you can see at the top, it's a bit of a clone written in Go. It's called Acme. Acme is very mouse oriented, and I like the mouse, but it gives me kind of pains in my wrist. So I needed a VI mode. So I made a sort of a clone with VI key bindings. It's work in progress, but it's already starting to work. I have to get it in a state where I can start using it for real, and then we'll go even. The development will go even faster. So that was the last application. Now back to the presentation. So you've seen it's real, it runs, it works. This is a very simple, small code example of an application. So you import a library, you have a main function, you create a new developer UI, you make a top UI. In this case, it's just a very simple button. It's a text, there's a callback here. You render it once, and then you go into the main loop, where you just select and get the inputs, which are mouse, key, that kind of stuff. Resize event is also one of those. So then you pass it back to the library to actually process it and do its stuff. If you click the red X in the corner, your program is done, so then you quit. This is the main loop. I didn't want to hand off my main loop to some other library, so I want to be, that's why you write out the main loop. Oh shit. We had lots of time, right? Okay, well, there's lots of cool ideas here. Unfortunately, I cannot share them with you. You have to come to me afterwards and hear more about them. So, thank you.
Apparently there's questions, and apparently he's going to be setting up his laptop. So while he's setting up his laptop, one question.
Well, support is one thing. No, it runs on Linux, BSD, macOS now. It probably runs on Plan 9, but I haven't tried it yet. And it will run on Windows. I just need this separate helper tool, of which all the parts are available because of its history and how I've done it. So I just need to have the time to really. More questions. Yeah, I've not released it yet. I need one more vacation, and then I can really push through and finish it and publish it. Soon.
So he's talking about non-open source at FOSDEM. Thank you.
I will be up.
Oh. Should I use mine? All right.
I sent you the link.
So his laptop died, so we're gonna use my laptop. Wait. Okay. It's leaving again. You're showing your email to everyone. That's brave.
It's okay. You can pay my bills. Okay. So I'm going to tell you a story about the project we had to do at work. and it's about columnar data storage in Go. Let's start by saying that all data is not created equal. You may have a bunch of JSON data, you might have CSV data, and all this is pretty nice until you end up having terabytes of that. And when you have terabytes of that, your task, should you choose to accept it, is to extract only some fields in multi-gigabyte files like this. So say you only want size and payload, and you don't really care about all the rest. Well, you start to do it, and you use encoding JSON, and it dies, or it's very slow. So then you say, well, let's be smart, and surely someone has solved this before, and people have done it. People that do big data, they have special formats to store this kind of data, and it's columnar data storage. Quick intro, if you've never encountered it. This is how you would represent data, or relational data. If you store it in rows, it looks a bit like this, a bit like CSV. If you store it in columns, you just flip it around, and you see that each of the rows there is one of these columns. Okay. So, and not only people have solved it, they have solved it multiple times. So there are two Apache projects, Parquet and ORC, that already do this. And then you say, well, I want to do it in Go. Do I have libraries in Go for these formats? Kind of. For Parquet, no. For ORC, yes. You say, well, perfect. You find this little library. This is the project description. Then you see, okay, work in progress, and that's the current support. So the build is passing. That is good. Coverage, error. Work in progress. And when you look at current support, write is empty, with a caveat at the bottom that says the write to support is in late stages. However, I do not recommend to use it yet. So let's see. Let's do some testing. I take an input file. I use the Go, or I convert it to an ORC file. Then I will take this ORC file and read it again. And then I will have data out. And my goal is to compare if what I get out is the same thing as I put in. Simple enough. So we do it with Go, with the library we saw. So we write the data with the Go tool. We read it with the Go tool. Data out is the same as data in. So much win. But you say, well, I may not be using this data only with my tools. What happens if I use some official tools? Well, you have C official tools, data in, segmentation fault, core dumped. So this is what it makes me think. As long as we only use their tools, everything is beautiful. The moment you need to do some interoperability, doesn't work. And if your reference tools crash, it means what you are outputting is not according to the standard. Well, it's open source, so let's fix it. Well, there's a document, and if you go there, there are some beautiful specs, some pages full of charts and graphs, and they are incomplete. So you have to reverse engineer the C and Java reference implementations because there are constants that appear nowhere. It's even funnier because there are constants in the Java and C reference implementations that don't match the ones that are in the Go implementation. So you're like, okay. So conclusions. We sent a few commits that fixed it for our case, which is a bit better than works in my machine because apparently it works on the developer's machine. We have converted a few terabytes of data, and now it works for us in our machines. If you try to use it and you lose data, don't blame me. In this case, the project was very clear and very honest about what they supported, and that is something we really liked. And this goes without saying, but any time that you're going to be pulling some library, please do your due diligence before using it. Trust, but verify. And to finish in a cheerful note, and I think it's why we are all here, we are starting to get to a point where we have libraries for almost anything in Go, and open source rules. Last thing, I lied to you. The Apache Foundation does not have only two formats. They have another one called Arrow that does kind of sort of the same. And the nice people at Influx Data have done a Go implementation for that. Thank you.
Thank you. So we are done. So thank you so much for coming. I hope you enjoy all of the talks. There was a lot of them. Big round of applause to all of the speakers because they were amazing. And a big round of applause for all the people that came in, but also the ones that tried and ended up outside. Thank you to those.